Hi everyone, it's a huge pleasure to welcome you today to the LeRobot Worldwide Hackathon. When we started the LeRobot project at Hugging Face in February 2024, we had no idea it would grow to where it is now, only 16 months later. With more than 100 code contributors on the GitHub and more than 8,000 members on the Discords, we've seen this huge growth participation in the open source robotics community. And we see that on the Hugging Face Hub as well. There is an exponentially growing 8,000 data sets that have been already downloaded more than 1.8 million times. And my deep belief is that this is only the beginning of the open source robotics revolution. With accessible platforms like the SO101 or LuckyWee and many others, robotics is becoming more and more accessible to everyone, from software engineers to students, from ML researchers to hobbyists. And together with the progress in generative AI, this points to a future where robotics will be a huge part of our life. And I hope open source robotics will be a huge part of this future. The hackathon happening today is a great testament to this amazing growing enthusiasm. Who could have imagined we would be able to gather more than 2,500 participants from all around the world on 5 continents? Half of you today are hosted in over 100 local hackathons in groups ranging from 2 to several hundred people. The other half are participating remote from everywhere as well. At home, in family, with friends, you're all extremely welcome. Today we're starting a marathon of 52 hours where you will learn, experiment, discover, solve problems, propose community contribution, and more than all, you'll discover robotics. We are so excited for you to have joined this project. In many cases, and for many of you, I'm sure this will be a huge step. Maybe the beginning of an amazing journey through the world of open source robotics. Now, I'm super happy to let the amazing LeRobot team dive in the details of what will happen over the weekend.
Welcome everyone to the first LeRobot Worldwide Hackathon. For those who don't know Hugging Face, we are a company that provides a platform for open source. We host a community-driven hub where anyone from students, hobbyists, to big research labs can share their AI models, datasets, and applications. On the Hugging Face hub, more than 1 million models and 100,000 datasets are hosted. Our goal is to accelerate the development of open source AI and to ensure it benefits everyone. And a bit more than 1 year ago, we noticed important progress in embodied AI and major breakthrough in robotics. We felt we could contribute to lower the barrier to entry by creating LeRobot. LeRobot is a full stack project that combines affordable robot designs and software tools to record datasets, train AI models, and run them on robots. And more concretely, we provide video tutorials to get you started with AI for robotics. First, you can order robot parts online, then assemble your robots, one robot to grasp, and the second robot used to teach the first one, as we can see in this video. Here we record the datasets of robot trajectories and a video from our laptop and phone cameras. Then you can train your AI for a few hours on a MacBook Pro or a PC with NVIDIA GPU. And you can run your AI on your robot and your setup to see what it has learned. And so here we are just playing with some Lego blocks, but already with 50 trajectories, we can get very high success rate. And since its launch in April last year, LeRobot became more and more used in the AI and robotics communities with more than 40,000 stars on GitHub. We are very thankful for that. And we are also growing as a community with more than 9,000 of us on Discord. And what's even more impressive to me is that all the datasets that are recorded with LeRobot are shared openly on the Hugging Face Hub, with more than 8,000 datasets. And thanks to this collective effort, everyone has now access to the largest open dataset for robotics. It's already the equivalent of 20 million hours of recording or 2,300 years. So we might soon get in the data regime that unlocks the ChatGPT of robotics. And two weeks ago, we released the first vision language action model, pre-trained on this community data, and able to run locally and dynamically on a laptop. For this hackathon, we provide all the code to fine-tune this model, which should increase generalization capabilities on your task. And here we are, starting an epic worldwide hackathon together, 3,000 builders gathered around more than 100 locations. This worldwide hackathon is an unprecedented event. Half people in local venues around the globe and half online. 55 hours of hacking across 6 continents, 24 time zones. Thank you all for making this hackathon one of the largest and the most ambitious ever planned. And it is heartwarming to see so many people from various nationalities coming together to turn the globe into a giant robotics lab, open to everyone for 2 days. I'm not sure we all realize that this weekend we are making history. And to provide you with starting ideas for this hackathon, we designed 5 tracks. Each track addresses one key aspect of embodied AI.
Let's start with the imitation learning track, which will help you to get a better understanding of how this technology works and how it can be used to automate your own tasks. For this track, you will need a robot supported by LeRobot library and access to a GPU. The imitation learning track will be your easiest way to get started with LeRobot, with the SO arms, Kosh arm, LeKiwi, or any robot that you have. A quick tutorial will get you through the first steps to assemble, set up, and calibrate one of these arms and learn how to teleoperate them with a leader arm or a keyboard. Once you get familiar with teleoperation, you'll be able to record your first dataset where you will demonstrate to your robot how to perform a given task. Based on this dataset, you will then train a robot policy able to replicate the demonstrated behavior. You can first investigate simple models like ACT, and then experiment with more advanced ones like small VLA. To dig a bit further, here are a few advanced ideas you can explore. Asynchronous inference, which allows for a more dynamic and a better adaptation of the robot actions. Online corrections, possible with the new SO101 leader arm. And data augmentation, an alternative to create more robust and diverse datasets, whether it be on real robot or simulated data.
As a follow-up to the imitation learning track, the robot team is pleased to suggest an exclusive track on reinforcement learning. For this track, you will need a local NVIDIA GPU for training, your main SO arm, and a device for teleoperation that can either be your typical leader arm, your gamepad, or even your keyboard. Contrary to imitation learning, reinforcement learning requires online interaction data. You can observe your robot exploring its environment and occasionally finding the right actions that lead to success. In our implementation of HIL-CERL, we combine several techniques like offline reinforcement learning, human interventions, and distributed actor-learner architecture to achieve sample-efficient learning for tasks on the real robot. By following our tutorial, you can learn how to set up all the elements related to the real robot and RL parameters. You can then expand on the complexity of the tasks or develop different elements of our RL stack as you wish. In the case where you don't have SO arms but still want to try reinforcement learning, you have the possibility to set up a simulation environment that is fully supported in our RL stack. Using the GIM HIL suite from Hugging Face, you can teleoperate a simulated robot to provide demonstrations and perform interventions during online learning.
Regardless of the approach you're taking for training policies, at the end of the day, you'll still need robots. With the third track, we challenge you to extend LeRobot by adding your own robot. Integrating a robot within our framework allows you to leverage LeRobot ecosystem of data collection, visualization, policies training, and control pipelines. This can unlock a whole lot of opportunity and have a massive impact. For this track, no need for an expensive GPU. Obviously, you'll need some hardware. or ideas and materials to create new ones. Design your own robot with already supported hardware or bring your own. We'll provide you with a dedicated tutorial on how to do that. Then, build it using 3D printed materials or pre-made parts. Don't limit yourself on the form factor and let your imagination run wild. When you're done, bring it to life and show us its capabilities. This track is a great opportunity to dive deeper into core robotics topics: mechanics, electronics, and control systems. Finding ways to control robots efficiently and precisely is also key for collecting high-quality data, which in turn gets you the best results when training policies. From the game controller to the digital twin or the VR headset, possibilities are endless. Try addressing this track with a teleoperator instead.
Opening the door for more people to own robots broadens LeRobot field of application. Fortunately, there are numerous ways to improve open-source robots hardware and make them more efficient, more flexible, and adaptable to emerging use cases. Following the first track, you're going to join this enhancement effort and suggest a hardware improvement yourself. No need for a GPU for this track, but you'll need to have one of the robots supported by LeRobot to experiment on. After a quick tutorial to get you through the assembly, setup, calibration, and teleoperation of your robot, you'll be challenged to come up with your own original hardware improvements. As these models are open source, there is an infinite ways of improving them. But here are a few ideas to get you started. A new grabber is, for instance, a simple yet impactful way to shake up your grasping performance. You can adapt it to the robot's head vector and the task at hand. Another sensible possibility is to investigate more versatile camera mounts and add-ons with innovative features: different view angles, position, automatic light adaptation, implicit stereo vision. Feel free to get creative. If you think that a complete different mechanical design could make a difference, try it. This track is also a unique opportunity to tackle a hot topic among the LeRobot community: new sensors. LiDARs, depth camera, even cameras, touch sensors, a wide range of sensors remains to be investigated and embedded on our robots. We would like to put a particular emphasis on audio sensors, and especially microphones, as we observed they were a capable yet cheap alternative to touch and contact sensing. Furthermore, the audio modality may be easily integrated in a seatbelt policy like ACT, using a spectrogram representation of the audio waveform. What about trying this with your own microphones or your own sensors?
Finally, the last track of this hackathon. This track is about recording datasets and solving community issues that arise when we work together to collect data. With this track, you're going to delve into the range of possibilities for improving robotic datasets. And this could be in terms of the data itself or in improving the user experience handling the data. This track can be followed without a robot or a GPU. What you can do is improving and creating tools to streamline data collection, simplify data curation, and adding more modalities. This is crucial to train robust and generalizable models. And to get a better understanding of these challenges, you will first use a real robot or a simulated one and record your first data set. You can easily do this with the provided tutorials that will help you along the way. Additionally, you can also get a glimpse of the diversity of LeRobot datasets using the online data visualizer, where you can explore datasets from the community. Here are a few leads to help the community address these challenges. You could, for example, make the recordings of datasets more efficient or improve tools regarding datasets. For instance, one could train another robot to automatically reset the training environment between two episodes, or you could create a Hugging Face space in which you can connect a robot easily using Web USB, as shown in the videos on the slide. The ultimate dataset edition tool would be a Hugging Face space where you can delete, crop, merge datasets, rename observations, and even provide data augmentation features. it could then be further improved with a tool to evaluate, for example, the quality of an episode inside a dataset based on explainability methods. Finally, following up on track 4, you could add support for new sensors into the LeRobot dataset format. This helps promote diversity in recorded modalities, and additional modalities could be point clouds, depth frames, or asynchronous events. The potential in this is infinite, and doing this track is a great opportunity to get an in-depth understanding of the LeRobot dataset format.
And now the event guidelines. We only have 3 rules. The first one is to have fun and help one another. The second is to submit 1 demo video per team under 1 minute long and upload your datasets if relevant. All guidelines for submission are on Hugging Face of LeRobot Worldwide Hackathon. And the last rule is that the submission must be in by 6 p.m. local time on June 15. In collaboration with Seed Studio, we prepared the equivalent of $15,000 in robot hardwares for 30 winning teams. And we will have 4 criteria: creativity, technical difficulty, usability, and real-world impact. But also, you don't need to fit at all 4. So for example, it can be really creative and fun, but totally useless, and that's okay. Or the opposite, it can solve also a real problem, like a painful problem. That would be nice also. Among the prize, we offer 5 Open Junior, which is our recently released robot arm and hands with its teleoperation and exoskeleton. Then we offer 23 Lucky Wii, which is a mobile version of the SO101. And finally, we offer 5 SO101, which you can use to automate bimanual tasks, for example. On June 16, our team at Hugging Face will select 30 amazing video demo, and we will decide the ranking together through vote on Discord, and the winners will be announced the day after. A few communication advice: start our GitHub repository. Second, post your question on Discord channel forum. And also, before posting a question, search first. Your question might already be answered, and pick the right tag. Also, don't hesitate to be specific, including relevant details. And finally, Hugging Face team and community will be here to support you throughout the weekend. So let's build together. This is happening thanks to everyone's involvement and all the sponsors. So we are really grateful to have you all on board. And now it's time to start. And so good luck and happy hacking.
Hello world.
Hello Hugging Face and LeRobot.
And hello to all the robot hackers and builders around the globe.
Welcome to Munich.
Hey, salut, hola from Toronto, Canada.
Hey, I am Dr. Chua and I represent the Selangor Human Resource Development Center as the head of Malaysian Smart Factory.
Hi everyone, it's Benji from Roboto AI. We're super excited to be hosting a LeRobot Hackathon here in Seattle.
And good day from Australia, Perth, Australia. We're looking forward to the LeRobot Hackathon.
Bem-vindos ao LeRobot São Paulo.
Welcome to Aachen, Germany.
Hello from Seoul.
Hola, os damos la bienvenida al Instituto Rafael Alberti en Cádiz.
Hey everyone, Daniel from the Brainwave Collective, saying hello from Denver, Colorado.
Hey everyone, I'm here at the site of the Los Angeles LeRobot Global Hackathon.
Hi from Mexico.
Hi, I'm Sandy from New York City.
Hugging Face LeRobot Hackathon in Melbourne.
Hi everyone, I'm Clem. I'm the co-founder and CEO at Hugging Face. I wanted to thank you everyone for joining the worldwide LeRobot Hackathon. I'm going to be attending the Miami version of it It's turning out to be a historic moment for AI in robotics, with people participating in over 100 different local editions and online all over the world. So have fun, everyone. Don't forget to share on social media all the fun, interesting robots that you're playing with, that you're building. And I'll make sure to retweet and reshare all these social media posts. Let's make altogether robotics more open and collaborative. Let's go, everyone. Thank you.